Today we're going to jump into chapter 4 and really going to primarily focus on the financial side of life, really, over these next few lessons. First one takes advantage of a very important principle, simple interest. And so simple interest, again, you can think of it as a convenience fee for allowing some entity. So it could be like a bank, it could be student loans, right? We'll talk about those. It could be a car loan. We'll talk about those. Credit cards. You're essentially allowing some entity, or they are allowing you to utilize their money for like a convenience fee, if you will. So here's some other examples. Savings accounts, CDs provide interest to you. But credit cards or loans, any loan, a mortgage, things like that, the bank is basically giving you money up front and you owe them money in return for giving you all that money up front. So that's typically how those work. The term principal here is going to be the amount that we initially give, and interest is paid as a percentage of that principal. So here is the simple interest formula. Excuse me. And you'll notice really quick that this formula is just dealing with interest on the left-hand side. P stands for principal. The rate is our interest rate, and we are going to be using this as a decimal. So that's the reason why we went through that content already, converting fractions to decimals and vice versa. And then also T is going to be our time. This is mentioned typically in years. However, there are such things as like short-term loans. So like 3-month loans, 6-month loans, 45-day loans. And we'll approach T a little bit differently in that case. We'll go through some examples, so hopefully everything will work out. You'll understand it in the end. So when you borrow money, the total amount to be repaid, so just to distinguish here, this is purely interest listed right up here. This is purely the interest formula. But when you're paying back a loan, you're not just paying back interest. You're typically paying back how much you borrowed plus whatever interest you've accrued. So in a way, what's happening is this is the total amount. There's a formula for that, and we're actually going to deal with it down here. But these are called maturity value or future value formulas. Okay, so that's the combination of the amount that you borrowed that you owe back plus the interest that you owe as well. So these are really crucial formulas for simple interest. And again, we're going to really dig into these when we talk about mortgages, car loans, student loans, all that kind of stuff here in this chapter over the next few sections. These are really the primary formulas that we use. These are all the exact same formula. They're just a few things changed out. So if you notice, this top one here is A, which is, we call this the amount that you're paying back. P is going to be the principal, so that's how much you borrowed. And then I is however much interest you also owe. Well, we can make this formula swap here. If you notice up top here, I've got I is equal to PRT. And all I did in this second equation is I just swapped out the I with PRT. That's all that we're doing. In this third equation, I went a step further and I factored, this is some algebra if you're comfortable doing it. We'll do a little bit in this class, not a whole ton. A lot of it is just going to be moving things around and solving for variables and stuff like that. So what I did here is there's a P that is represented in both of these pieces commonly. And so as a result, I can pull it out because it exists in both and then leave behind what's remaining. So in this instance, it's just 1 plus RT. So again, these are just 3 variations of the exact same formula. They all represent the exact same thing. So A is the amount after the interest. I has been the amount added to the principal, which is the interest amount that you are paying. And then P is the principal. Rate is R, T is time. Again, R is going to be a rate, which is a percentage. or a decimal. It's a percentage converted to a decimal. So we're going to be using the decimal form. And let's go through some examples here. So that's kind of the gist of content. We'll be going through quite a bit in terms of the value, because there's a lot of uses of simple interest. So let's go ahead and switch over to whiteboard, Blackboard. So for this first question, what I want to do is I want to find the annual simple interest rate. Looking for the rate. So it's important to know specifically the thing that we're looking for. So we're looking for a rate here on a loan. And one thing you can do when you're working through these word problems, by the way, I want to mention there's going to be a lot of problems in this class. And if you're an international student or English is not your primary, on YouTube, I have captions that you can go and click that little CC button at the bottom right of the video, and then you can change the language to whatever you'd like. It won't change the language of the text that I write, but if you want to use an actual translator for this text, feel free to do that. But I just wanted to mention that. What I like doing is I like writing these things out and seeing, kind of underlining key things. So in this instance right here, I'm looking for the rate. So that's R. That's the thing I'm looking for. On a loan, which is a 3-month loan. So this kind of refers back to what I mentioned earlier. $500 if the maturity value. So again, this is another thing, maturity value, future value, it means the same thing, is this is $5,000, sorry, not 500. 5,000 if the maturity value is $51.25. Okay. So let's go ahead and write this out. The maturity value we're using the formula A is equal to P. And I'm going to use that second one down just to kind of show you how this all works to begin with. So let's go ahead and start. We know the maturity value, which is the amount. This is going to be $51.25. The principal is $5,000. That was the amount that was initially given to me. Okay. So I'm going to rewrite that thing out right here. And I'm multiplying by the rate times the rate. And I'm multiplying by the time. Now, this is the question. The time in the notes, if you look, is always represented in terms of the time here is not in years, it's in months. So what we need to do is convert 3 months into something that's represented by a year. So you can do the following. I can take the number of months or whatever unit I'm using and divide it by the total number of months in a year. So 12 months in a year, this is going to be the 3 months that we are using reference to this. So 3/12 is the same as 1/4, okay? That's kind of the idea here. And you'll get more comfortable doing this because we'll do quite a few of these. So just again, bear that in mind. Okay, so now let's go ahead and solve this. So there's a couple of important things to know. When we work through problems and we're solving for variables, you may remember back when you were a younger person, the order of operations, there was a sentence I used to use all the time. Please excuse my dear Aunt Sally, or PEMDAS, right? When we're solving for a variable, we're actually doing the backwards process on that. So what we need to do is take care of our addition subtraction first, then we do our multiplication and division, and hopefully we'll get the R by itself. So what we're going to do is we're going to subtract 5,000 from both sides, first and foremost. so that means I've got 125 here. I can't subtract this 5,000 because it's multiplying. Okay, so I just want to point that out. I have to do this one by itself because it's being added to the other piece. So this is going to be 125 bucks right there. And now I've got 5,000, and I'm going to rearrange this so the numbers are right next to each other. I'll reduce this down to a quarter because 3 divided by 12 is 1/4. It's the same thing. And then I've got my R. 5,000 times a quarter. Let's go ahead and do that first. So 5,000 times a quarter. And by the way, if you've got a calculator, which we're going to be using this calculator here quite a bit. Let me go ahead and switch over to, this is a TI-84. I've got it built into my computer here, but we'll be using this quite a bit. Feel free to use this, you know, whenever you want. So 5,000 times 1/4. Punch it in, 1250. Okay. So switch back. This is going to be 1250 here. That's kind of a nice comparison. And we're still multiplying by R. To get this number by itself, this is what we call a coefficient. It's a number that sits in front of a variable. All we're going to do is now divide, because the multiplication, the opposite operation of multiplication is division. So we'll go ahead and opposite of that. 1250. Okay. And again, you can go back calculator if you want to. I can take 125, divide through by 1250, and I get 0.1. R is equal to 0.1. I just wrote this. So this is 0.1, or you can think of it as 0.10, which is the same thing as 10%. So that right there is our interest rate on that loan. All right. Let's go ahead and do another problem. So on this one, very similar process. We have a 3-month loan. So find the annual simple interest rate. So again, we're looking for R. That's the missing value. Find the annual simple interest rate of a 3-month loan. So 1/4 of a year, again, as the prior problem was, of $3,000. So this is my principal, right? Which has a maturity value. Oops. Value. There we go. Handwriting is all jank. That's an A, remember? Of $3,105. One of the things I really want to encourage people to do when they're working through these problems, you know, I know this, you might be watching these videos if you're taking an online course, but write these things down in your notebook. There's something about writing that when you are writing something and you're listening to something and you're reading something, utilizing multiple senses actually does help in the learning process. And so if you're just watching this, you're not going to get as much as if you were to write this down while you're watching it. Okay. I don't really know how you can involve smell and taste in the learning process for math. Maybe if you want to have like a glass of chocolate milk or something, I don't know. That's like one of my favorites. Anyway, yeah, let's go ahead and jump into it. So let's take a look really quick. I'm going to show you a different way to solve this if you want, and then we can go ahead and do it. So if you recall, the formula This is one variation of the formula that we had in the notes, okay? This is the first variation. The second one is the one that we used in the previous problem. What I can do is I can determine the I and do this kind of in a piecewise process. So my interest is equal to my P times R times T. So let's figure out what this is first. I know that this is going to be the difference between how much I have to pay back, the 31. Actually, so I don't really need the PRT formula here, okay? But just look really quick at the equation, or what the words are here. It has a maturity value of 3105, right? But I borrowed 3,000. So the difference between those two should be the amount of interest that I'm actually paying. I hope that makes sense. So 3105 minus 3,000 is actually the amount of interest that I paid. So in this instance, man, I cannot talk today. $105. That's how much interest I paid. Okay. My principal is actually going to be my 3,000, right? So essentially, if you look at it like this, right? Let me erase this. I'm not going to need this. Back. Sorry. My interest is this. My principal is 3,000. My time, we already established in the prior problem, it was a quarter of a year. Right? 3 months is a quarter of the year. So the annual simple interest rate, if I use the formula I is equal to PRT, I can go ahead and do 105 is equal to 3,000 times R times 1/4, right? So I'm using just the straight interest, the simple interest formula. I'm not using the maturity value. I could go and use this exact same problem, using the A is equal to P plus I, or A is equal to P plus PRT. I could do that. That's fine. I just wanted to show you a different way to work on this problem. You may like this way better. You may like the prior problem, the process I went through in that question. That's fine. Again, choices is kind of where I'm at today. So let's go ahead and calculate this. What I'm going to do is, since this is all multiplication, I can do anything in any order. So 3,000 times a quarter, right? And let me switch back, and we'll just do that really quick. 3,000 times 1/4. 750, okay? So 750 is our value here. Whoops, sorry about that. 750 times R, and this is 105. And now all I have to do is divide both sides by that value. And what I'm going to get, left-hand side, back, 105 divided by 750, 0.14, 0.14. So R is equal to a 14% interest rate. That's a lot for a loan, it's going to be honest. Should not be taking out loans at 14%. That's going to be paying quite a bit interest. Okay. And as we start working through this chapter, you'll understand why, how high interest rates really are and what they can do. Anyway, okay. Let's go ahead and do another problem. So suppose I deposit $650 into an account paying 7.7%. So a deposit, write down the info, $650 in an account paying 7.7%. So I want to find the future value Remember, future value is the same thing as maturity level. It's that A value after here. Okay, so got my amount. This is equal to P plus PRT. We'll use that second variation. My amount, I know P is equal to 650. That's how much I'm borrowing. And I'm paying 7.7%. Now, the common mistake that people make here is they plug in 7.7 for R. Here is what is important to know. R is equal to 7.7%. We need to convert this to a decimal. So this is going to be 0.077. Okay. We shift the decimal 2 places to the left when we convert from a percentage to a decimal. So this is the actual number that we're using in place of R in that equation. So this is going to be multiplying by 0.077, and the time is 1 year. So this is just going to be 1. Remember, T is always in terms of years. So as a result, I can go ahead and compute this. I'm just going to punch this into my TI-84. So 650 plus 650 times 0.077 times 1. I don't really apply it times 1. Whatever, I can put it in. Makes no difference. $700, 705 cents. Throw a nickel in there, I guess. I don't know. $700.05. So this is the maturity value after. All right. Let's do another one. Calculate the simple interest. Simple interest on a 40-day loan. 40-day loan of $4,800 if the annual interest rate, so they give us the rate, so that's nice, is 9%. So we're not looking for any future value. We're looking for the simple interest, right? Calculate the simple interest. That's I. So I is equal to PRT. It's a bad R. Let me try that again. My handwriting's not that great with some letters. I've gotten complaints before. Not like from online students, but apparently my B's and 6's look similar. Same thing with my R's. Sometimes they look like V's. So working on it. There's always room to improve. I is going to equal, the principal is the amount, the face value. That's another term for it, by the way, the face value. The amount that you borrowed, 4,800 times. If I say some words that, hey, you didn't define what that was, part of the reason why is because my graduate degree was in kind of financial mathematics, and so it's just kind of like it's in there, you know. So it might come out periodically, and you might be looking at yourself like, what the heck is he talking about? That's just how it is. Okay, 4,800. The rate is 9%. So remember, R is equal to 9%. We need to convert this to a decimal. This is going to be 0.09. And then multiply that by the time. So 40 days. This is where it gets a little interesting, because we, for the purposes of this problem, are going to assume, I know this is kind of weird. This isn't how it actually works, but for the purposes of this problem, I am going to assume that a year is 365 days. Okay. Technically, there's like an extra quarter of a day. This is the reason why we have leap years. Whatever. It's fine. Imagine it's 365 days. Okay. So I'm going to take 40 over 365. All I have to do is multiply every single one of these things out, and I'll know exactly what my interest is. So let's go ahead and go back to our TI-84. Gotta go. 4,800. Multiply it by 0.09. You can do 0.09 or 0.09. It doesn't make a difference. Same thing. And then I'm going to multiply by 40 over 365. Okay. The homework problems, they might say that use 360, like 360 days for a year. I'm just going to go 365. It makes no difference. Again, well, it will make a difference in the answer. Just go by whatever the problem tells you to do. Okay. If they don't specify, it's 365. If they do specify, then it's 360. Or if they do specify that it's 360, then use 360. That's my point. Anyway, hit enter. And this is the amount of interest that I will pay on this loan. So 47, what was it? 47.34. $47.34. There it is. All right. Do another one. Just love doing these problems. I know like people are a lot of times people are like, come on, get to the interesting stuff. This to get to the interesting stuff, we have to know kind of like this stuff. So when we start getting into like mortgages and credit cards and student loan stuff, maybe it's not interesting to you if you have an abundance of those things, significant amount, but we'll talk through it. Forwards, gotta go backwards. Here we go. Okay, so let's go ahead and do another one. We're going to find the future value. So again, remember, terminology is important. Future value. Find the future value. So that's another word for A. Find A of a 2-year investment. Okay. Of $6,225 into a simple interest account. That has, just fast forward this if you need interest. .4%. Okay. So again, on the side, immediately 3.4%. I'm going to convert this to 0.034. Remember, I moved the decimal to the left 2 places. So I'm looking for A. So A is equal to, let's write out the formula first. We'll do P plus PRE. We'll do that second one down just to be consistent here. So I know the principal. I know that's 62.25. I know the rate, which is 0.034, and I know the time. The time is 2 total years. So my amount is equal to 6225 plus. In this one, you can use the calculator pretty easily. The first one I did, I think we were solving for R, so we actually had to do a little bit of algebra to get it by itself first. But in this instance, it's a pretty straightforward process on the calculator. So 6225 times 0.034. And this is another way of writing multiplication, by the way. You can use the dot or the cross, little multiplication sign, or you can just write things in brackets, parentheses like this. it works exactly the same too. All right, so got our amount, and we just have to go ahead and punch this in now. So switch back, and I've got 6225 plus my 6225 here times 0.034 times 2. And you can see I'm doing it in brackets just to illustrate. You can do the same thing in the calculator. You can use the multiplication sign, that's fine. Or you can do the brackets, it'll work out identical. So this is the total amount of money that was in the account at the end of the investment period. So back, that would be $6,648.30. Okay. All right. All right, let's do another one. We're going to find the future value. Find future value. By the way, again, there's a lot of great resources in the textbook, great videos. Well, I would encourage you to take advantage of that. Some of the videos are probably better than mine, so yeah, go for it. They have a little bit more content in there. Like we're not going through everything in the textbook, but if you do want to learn a bit more about these topics, you know, if you're in the trenches, as you will, of life, you're, man, I want to learn about Treasury T-bills, feel free. We are not going to be talking about those. So we're putting this into a simple interest. By the way, most of these accounts, this is again for examples. The next session that we'll talk about is 4.2, and we're going to be talking about compound interest. It's a little different, but most things operate on a compound interest basis. It's not simply just simple interest. Account. This is more just to. It has. Annual rate. 5.5. Okay, so as a reminder, swap that immediately. 5.5%. We're switching it to a decimal, 0.055. So I'm looking for future value. That's the A value, right? 3,500. There's my P. 18 months. This is going to be my time, right? So this is actually 18 over 12. I'm kind of at the border of where I'm at. I'll write this down here. So A is going to equal P plus PRT. And I have to determine what that amount is. My principal, 3,500 plus 3,500 times my rate, 0.055, and my time. 18 over 12, you can write it like that. That's fine. We'll just do that. Make it life easy. And then again, this is all calculator work. There's gonna be a lot of calculator work in this chapter, but and I'll include like if you want, you can use like some Google Sheets to do some of this financial stuff as well. And so I'll kind of talk through a little bit of that if you're interested in kind of converting some of this stuff into spreadsheets to make life a little bit easier. I love spreadsheets. They're live basically in them. I do a lot of tracking, student data, all that kind of stuff. And so they are a very, very valuable tool, and they're a very marketable skill if you're going and getting a job. So that's my soapbox. Learn how to use spreadsheets. They're fantastic. Let's go ahead and punch this in. So this is going to be 3,500 times 0.05, 18 over 12. So remember, 18 months. So the numerator is 18. The bottom is 12, purely because that's how many months are in a year. So we've got, basically it's a year and a half, right? 1.5, 18 over 12 is the same thing. So when I punch this in, that is the total amount in the account. So $3,788. So 3,708. That's it. Okay, that's my final value. So that's pretty much all we got. This was a little bit of a class. Some of these are a little others, but yeah, I just wanted to kind of go through this and work through as many problems as you can. I think when we get into like a lot of the financial math, having numerous examples is going to be really essential for us as we work. So if you have any questions, feel free to let me know or reach out. But that's all I got for today, and I hope you have a great day. Enjoy.